Alright folks, welcome back to the AI Research Roundup. It's May 5th, 2025, and I'm your host Alex. Today, we're looking at this ICLR conference paper, published back on January 22nd, so about 3.5 months ago, titled, Transformers Provably Solve Parity Efficiently with Chain of Thought. This paper theoretically explores how training transformers using chain of thought, that's CoT, generating intermediate steps, helps them tackle notoriously hard problems like K-parity compared to standard training. Okay, so this figure illustrates the recursive data generation process the transformer uses. Part A shows the basic idea, generating intermediate states step by step, using previous tokens to predict the next. Building on that, Part B shows the filtered generation using data augmentation, which is key for that self-consistency approach we mentioned. It helps the model check its own work, essentially, allowing it to learn efficiently, even without direct, intermediate answers. So this figure here shows how the K-parity problem itself can be broken down hierarchically. We see an 8-parity example, where the final answer y is computed by combining intermediate parity results from lower levels, all the way down to the input bits. This decomposition is key. It's the structure that the chain of thought approach leverages, enabling the transformer to solve the problem step by step, which is much easier than learning it end to end. Building on that hierarchical structure, this figure shows the causal masks used within the transformer's attention mechanism. The left mask is for training with teacher forcing, where the model gets the correct intermediate steps. The right mask is used without teacher forcing, likely for that self-consistency approach. You can see the structure is different, controlling how information flows based on whether those ground truth intermediate steps are provided or not, which impacts the learning efficiency. Okay, moving to the results. This figure plots the loss curves during training. We've got the CoT loss on the left and the final prediction loss on the right. Notice how direct training, the red line, basically flatlines, failing to learn. But look, both CoT with teacher forcing and CoT with self-consistency show rapid drops in loss. This really backs up the theoretical finding that intermediate supervision makes learning parity much more efficient. Yeah, and looking closer, these plots actually show this for different complexities of the parity problem, k equals 32, 16, and 8, from top to bottom. Across all these, the story holds direct training struggles, while both CoT methods learn effectively. The self-consistency approach, the green line, works almost as well as providing the direct answers via teacher forcing, the blue line, which really emphasizes the power of that internal checking mechanism. So wrapping up, the theoretical analysis really confirms what we saw in the experiments. Training transformers to generate those intermediate chain of thought steps. It just makes them incredibly efficient at tackling problems like parity, which are otherwise really tough. Well, whether through direct supervision or self-consistency, CoT provides a clear path to learning complex functions. That's all for this week's AI Research Roundup. Thanks for tuning in. I'm Alex, and see you next time.